Yeah, welcome everyone for the today's session. Welcome all the students, SPOCs, principal and faculties. Welcome Mr. Ramkumar from the Cisco for the taking time out for this networking protocol and TCP/IP model session. Thank you Anurag sir for the joining this session. Over to you, Mr. Ram.
Discuss about. Let me share my screen and start. So welcome to module 3. Today we are going to discuss about networking protocols and TCP/IP models. So in this particular modules, we have 7 topics. So I'll explain in depth and I'll give you some quick overview before jumping into this particular topics. The first topic is rules. Everywhere we have rules. In school, we have rules like we need to wear uniform, we need to wear ID card, and we need to wear shoe. So similarly, in networking also, we have certain rules. We need to follow those rules in order to have a successful communication. And protocols. So why we need protocols and what is the purpose of protocols in networking, that will be discussed in this particular protocol topic. And the next one is protocol suite. So protocols, multiple protocols are combined to form a protocol suite. It will help us in the networking communication, that will be discussed in the protocol suites section. And standards organization. So standard organization is one of the main function. It does assigning the IP address to the assigning public IP address, and it helps in supporting the network interoperability. For example, today we have Nitish Tangaraj. Do you have any questions? See your hand raised. Okay. So today, we have multiple vendors like Cisco, Juniper, Dell. So each one have their own software and they have their own hardware. So the standard organization helps in with the interoperability. So we can use Cisco hardware as well as Juniper hardware in your network. So the standard organization helps in maintaining the interoperability. And reference models. So we have OSI model and TCP/IP model. So that will be discussed in the reference model. So then basically the network. So the network is built based on the layers. So in OSI layers, we have in OSI model we have 7 layers. So those will be discussed here. And data encapsulation. So when we are transmitting data, so how the data is encapsulated from the sender side and how it get decapsulated in the receiver side, that will be discussed in this topic. And in the data access topic, so how from the NPC you are connecting to network and how you are accessing the resources, that will be discussed in the data access topic. Let's go to the first topic, the rules. So so in networking, there are 3 main elements. One is sender, receiver, and media. I'll tell you one real-time example. So consider we have 2 friends, Suresh and Ramesh. So Suresh, he want to wish a happy birthday to Ramesh. So he is sending a message in WhatsApp like happy birthday to Ramesh. So here, the Suresh is the sender and the Ramesh is the person who is receiving that message. So he is called as receiver. And media, you are using WhatsApp to send this message. So the WhatsApp is media. So in order to have a successful communication, you need sender, receiver, and media. So, so in networking, all the communications are governed by protocols. So protocols are nothing but its set of rules. So every protocol has its own functions. So for example, in this particular diagram, the PC1 want to send some message to PC2. So here PC1 is the source. It it converts that message into signal, that is a transmitter, and then it sends a message in the wired through the transmission medium, that is called as wire. And once the sender receive the receiver receives the message via signal, and it will be, then they will open that message and they will see it. So individuals must use established rules or agreement to govern the conversation. The first message is, so here, so whenever you are communicating something to the opposite person, it should be in a formatted, and the person should able to understand. For example, the first paragraph, it is very difficult to understand, and it is not in a formatted way. So here there are some words which is not in English, it's in different language, so we are not able to understand it. So anyone who is reading the first paragraph, they can't understand what it's trying to say. But if you see the second paragraph, it is in a proper formatted way, and it's in a proper English. So we are able to read, and we can easily understand. So rules govern communication between human. It's very difficult to understand messages that are not correctly formatted and do not follow the established rules and protocols. So what it's trying to say is we need to have a proper format, and then only we can easily understand what you're trying to say. So protocols must account for the following requirements: an identified sender. So these are all the requirements for any protocols. An identified sender and receiver, common language and grammar, speed and timing of delivery, confirmation or acknowledgement requirement. I'll tell you one example to understand this. Consider one person, so he want to withdraw some money from ATM. So he is, so consider his person name is Suresh. He is asking someone like, where is ATM? So here the person who is asking question is sender, and person who is going to tell him the way to the ATM, here he is called as receiver. So we need to have a sender, we need to have a receiver. So common language and grammar. So both of them should have a common language. For example, if one person speaks in English and other person
Yeah, I'm audible. Hello.
I think there is some technical problem. So Mr. Ramkumar will again join. He's trying to rejoin the session.
Yeah, you are audible.
Okay, fine. Sorry, suddenly my network got disconnected. So let me share my screen. So encoding is the process of so Anurag, till where till when I got disconnected.
Hi Priya, are you able to hear Mr. Ram?
Yeah, yes. Hello. Yeah, I can hear.
I am audible, Mr. Ram.
Yeah, yes. You're audible. Am I audible now?
Yeah. Now it is fine.
Okay. So let me share my screen. So am I audible now? Shall I start?
Yes, audible.
Okay. So message encoding. Encoding is the process of converting information into another acceptable form for transmission. So here what happens is this source PC it's going to encode the message in the signal format, and it transmit via the cable. So this is called as transmission medium, and once it reaches the receiver PC decodes the message, and it's going to give the message and read and give a response. So this is called as message encoding. So in source side, message encoding happens. In the destination side, the decoding happens. So message formatting and encapsulation. So when a message is sent, it must use a specific format or structure. For example, if you're sending some letter to your friend, 1 minute. 1 minute. So when you are sending a message to someone, so you will specify the from address and to address, and in the outside the envelope, and so you will send it. So similarly in networking, we have the source IP address and destination IP address. This is treated as the sender address, from address, and to address. So every message should have the source address and sender address and the data. So messages sent across the network are converted into bits. So for example, if you are sending, if you want to send some file in the network, suppose if the message size is 1 MB, it is not sent the complete 1 MB in the network. So what it's going to do is it's going to divide the 1 MB file into smaller pieces, and it's going to send it in the bits, so that it will be easy to transmit, and the receiver can easily get the packets, and it will be sent in a sequence, like one packet is divided into multiple packets, and it will send to the destination. Message timing. So message timing includes the following: the flow control, response timeout, and access methods. So whenever the message is sent, it should be sent in the average speed which it can be delivered. And response timeout. So if you are sending a message and the destination has to wait for some time until it receives your message. So access methods determines when someone can send a message. So there may be various rules governing the issues like collision. So in networking, so collisions can happen like if the same person's talking at the same time, then it is called as collision. So the one person to speak has to speak first, the other person has to speak second. So then only we can understand what he is trying to say, and this avoids the collision. Message delivery options. So there are three types of message delivery. One is unicast, multicast, and broadcast. So unicast means so you are sending a message to one-to-one. That is called as unicast. So if you are sending a message to a group of people, that is called as multicast. And if you are sending message to all the people, that is called as broadcast. So I'll tell you one example. Consider in your WhatsApp account you have 50 contacts, and you are sending a message to only one person. That is called as unicast. And you have a WhatsApp group like friends group, family group. Consider there are 10 members in that group. You are sending message to only that 10 members is called as multicast. And if you are sending message to all 50 people to all your contacts, then it is called as broadcast. So this is the graphical representation, like from one person to one. Even though we have multiple people, we are sending it to one person. This is called as unicast. Out of 5 people, we are sending to 3 people. This is multicast, and we are sending it to all the people. This is called as broadcast. So let's discuss about the next topic: protocols. So Anurag, it's so I'm audible, right? So there is no more disconnections.
Yeah, you are audible.
Okay. So protocols. So what is meant by protocols? As I said, protocols are the set of rules. It can be implemented in software, hardware, or both. So protocols have their own function, format, and rules. So there are different types of protocol. One is network communication protocol. In network communication protocol, TCP, UDP comes under the network communication protocol. And network security. Network security, so you are we have a Gmail, and we are logging in with username, password, and whenever you are accessing the bank website, we are using the HTTPS SSL, so that will comes under the network security. And routing protocols, like so you are accessing something from one place to another, so the routing protocols helps in identifying the best path and helps in forwarding the packets. And service discovery is used for like CDP, LLDP. These are the protocols. It will helps in identifying the devices which connected. So network protocols and function. So the protocols may have their own functions. For example, addressing, reliability, flow control, sequencing, and error detection. So these are all the main functions of the protocols. So in this example, this person is sending message in an IPv4 header. So this is the source, and the server is the destination. So he is sending some data to the destination. So the devices in between, which is receiving the data and it is forwarding it to the destination, should also understand the IPv4 header. Then only the communication is successful. Or else, if this person is sending a message in IPv4 format, and if this router is not able to understand that in IPv4 format, then it's going to drop the packet. So automatically the communication is going to fail between the sender and receiver. So your protocols should have the following functions in order to have a successful communication. So the protocol interaction. So we have different types of protocol, like hypertext transfer, HTTP, TCP, Internet Protocol, and Ethernet. So every protocol has its own functions. For example, HTTPS, which helps in your browser like Google Chrome, Firefox, we use HTTPS. So for example, if you're accessing some websites like Facebook, LinkedIn, so everything will be comes under the HTTP protocol. And TCP is one of the protocol. It helps in provides a guaranteed delivery. And Internet Protocol, so it helps in delivering the messages from one place to another place. And Ethernet is nothing but in every laptop we have the network adapter, network interface card. We used to say is a network interface card. It helps in connecting to the network. So next, we will discuss about the protocol suites. So the protocols must be able to work with other protocols. So each protocol has to support other protocols to get a proper communication. So the protocols work together in order to provide a proper communication. So here there is one example. So this person A in red color shirt, and there is another person. So he want to know the address of the nearest hotel. So what he is doing is he is going nearby that person and is asking like, where is the cave, or where is the hotel. So first this person, whatever this person is saying, this person has to hear. So they should be in nearby, or else if he is saying something and he can't, if he is in far distance, he can't understand what he is saying. So they should stand nearby. So similarly in networking, so every devices are connected directly or indirectly connected through the networking wired connection. So somehow this message has to reach this person. That is the physical layer, we used to say. And they should use a common language. For example, this person is speaking in English, and if this person, if he don't know English and you know only Hindi, then the communication is going to fail because he can't understand what he is saying. So first he has to wait for his turn to complete. So if he is asking what he has to speak, that is called as wait your turn. So one person has to talk at one time. So these are the, so we have different layers in the protocols. So we're going to see about evolution of the TCPIP is a mostly protocol suite. So it has 4 layers. network access layer has Ethernet, ARP, and WLAN, and IPv4, IC, and ICMPB transport, TCPIP, and DCP. So really, TCPIP is the protocol now, and we have other protocols as well, but it is proprietary. AppleTalk is it's a proprietary for a company, and Novotel Netcard is Novotel their proprietary. So it's not used commonly. So as of now, this TCP. So TCP, for example. So the TCP/IP protocols operate at the application transport and internet layers. So the common net access layer, the LAN protocol, and the LAN. So we have the network access layer, which the either is connected to it, and after that we have the source IP protocols, which helps in defining the source IP and destination IP, and the TCP, which helps in guaranteed delivery, and HTTP is the end protocol where we use it in the browser. So these are all the TCP/IP protocol suite. So in the network access layer, we have ARP. In the data link protocols, we have Ethernet and WLAN. So I'll explain you with an example. Like in network access layer, we have a Ethernet. So Ethernet is nothing but so you have a laptop, and if you connect with the wired cable, which is called as Ethernet, and WLAN, in every mobile phone we have Wi-Fi connectivity. So in internet layer, we have IPv4. I already mentioned so it's every should have a source address and destination address, and we have a TCP, UDP, and so this will helps in guaranteed delivery. So this is mainly the UDP is mainly used for the video applications, so where we don't need the acknowledgement, but in cases if you need acknowledgement, we use the TCP protocol. So in application layer, so we have the DNS. So if you're sending an email, it uses SMTP, POP3, IMAP, and file transfer for the application layer. So TCP application process, web server embedding and then web client de-encapsulate the web page for the web browser. So this web server, when it's sending a packet to the web client, it is going to encapsulate the packet in the Ethernet header, IP header, and TCP header. So this data is encapsulated with the three headers, and when it reaches the client is going to de-encapsulate the packet. It's going to strip the headers one by one, and then it will get the data, and it's going to process the data. This is the TCP/IP communication process. So let's discuss about the standard organizations and what is their roles and functions. So these are all the standard organizations. So we have IEEE, INA, ICANN, ITU, and TIA. So what they are doing, and what is their functions? So they help in supporting the interoperability. I'll give you an real-time example. What is interoperability? So earlier, so I think before 5 or 7 years, so every mobile phone has its own own type of charging cable. Like Nokia, Samsung, they use their own charging cable. But nowadays, if you see, every phone is supporting the Type C and mini USB. That is called as interoperability, and the USB as well. So we have the USB port. You can connect the USB port in any of the laptop, any vendor. So that is called as any interoperability. This particular organization helps in maintaining the interoperability and innovation. So these are all the standards. So currently they are following. And this is one of the main topic, the IP address, domain name, and TCP UDP port numbers. So we have seen, so the cybersecurity, they are able to identify the particular, if there is the email threat happened, the cybersecurity team can identify this particular email come from which place, from which address, how they are identifying it. So because this INA, this organization is going to assign IP block, public IP address block to the each region. For India, in India, we have a different public IP address. For Airtel, we have a particular block of IP address. For Jio, we have a particular block of IP address. So by that, if the particular email comes from which place, it can easily identify the address, and they can find out it comes from which service provider. So this INA is going to assign IP address to the ISP, internet service provider. Okay, 1 minute. Okay. So as I said, the Internet Corporation, for assign the names and numbers, coordinates IP address allocation. It helps in allocating the IP address, the management of domain name, and the assignment of other information. So these are all some of the electronic communication standards like IEEE, EIA, TIA, and ITU-T.
Ram, you are not audible.
So let's discuss about these reference models. So the reference model is nothing but it has a 7 layers. So the network is built based upon this reference model. So the TCP/IP is one of the protocol suite that built based on this reference model. So we have open standard interconnection, which has 7 layers, and the TCP/IP, which has these 4 layers. So we have, let me explain the different layers we have in networking. So the physical layer is nothing but the physical connectivity. For example, the Ethernet connection we connect to the laptop, and the wireless connection, which is the physical connectivity, is called as the physical layer. And in the data link layer, so we used to call it as a frame. So the data using the MAC address, source MAC address, and destination MAC address is called as a data link layer. And the networking layers, it provides the source IP, destination IP. It helps in exchanging the messages from source to the destination. And the transport layer, which helps in segmentation. As I said, like you can't send 1 MB. The 1 MB file will get divided into multiple smaller pieces, and it will get transferred across the network. The transport layer take care of those things, like if you're sending 10 messages, those 10 messages will be reassembled at the destination in. So the destination, they don't know this packet is this message came as a 10 message. So they at the end they're able to see the message. And the session layer, it's to provide the data exchange to the presentation layer. So the presentation layer, it's a representation of data transferred between the application layer services. It's going to present the data to the application layer. So the application layer is a protocol user for the communication. So for example of application layer is our the browser. So you're browsing some websites in the Google Chrome or Firefox, and similarly our Outlook, we use email. That Outlook is the example of application layer. The same thing, the TCPIP is also the reference model of OSI. So here we have only 4 layers. In OSI model, we have 7 layers. So the some of the layers are included in the embedded inside the another layer in TCPIP. So here we have 7 layers. So here the physical layer and data link layer are combined into the network access layer. So similarly, so the application layer, the session layer, presentation layer, and application layer are combined into a single layer in TCP/IP model. So this is what I'm trying to say, like session layer, presentation, application, those are combined into a single layer. And the physical layer, data link layer, they're combined as a network access layer. So next topic is data encapsulation. So segmentation of messages. Why we need the segmentation of messages? So if you are sending a message from source to the destination, if that file size is some 5 MB, so though that messages won't send in that particular size. So we are going to divide that message into multiple small segments, and we are going to send it across the network. So why we are doing like this is, this will increase the speed and it increases the efficiency. And also, if you are sending as a one file, if it is missed during the transmission, then you have to send the complete file again. But if you divide that message into small pieces, so whatever the pieces which is missing, you need to send only those things, resend only those message again. And sequencing. What is meant by sequencing? So if you are dividing a big file into a 10 small file, so you need to number each file as 1, 2, 3. So we need to sequence that file in different numbers, so that when it reaches the destination, they are going to reorder that file, and they will get reorder, and they will get the original file. So the PDU, so it's called as protocol data unit. So every messages will be encapsulated when it goes to the different layer. For example, this person is composing an email data. Here it's the data. The data, when it comes to the transport layer, it adds the transport header to the data. When it comes to the network layer, it's going to add the source IP address and destination IP address. That is called as network header. In transport header, it is going to add, if it is a TCP, it adds the source port and destination port, and UDP also, it adds its own source port, destination port. And it comes to the data link layer. In data link layer, it's going to add the source MAC address and the destination MAC address. So this is one of the graphical representation. So the Ethernet frame, and it encapsulates in the IP packet. In IP packet is again encapsulated into the TCP segment, and again the data is added, and it's into the destination. So I'll data access. I'll tell you one. I'll open the packet tracer and give it with a real-time example. So this is a PC1. If it's want to send a message to PC2, I'll show you how the message is transmitted from here to here. So let me go here. I'll give a ping command. 72.1.2. So if you see here, the message, I'm sending a message from this PC to this PC. So first the message is coming here to this switch, and then again it's going to this router. Again it's going to this router, and it reaches the PC. So this is how a message from this PC reaches this PC. That is explained in this data access layer. So we have a network layer which deals with IP address, and data link layer which deals with MAC address. So I'll tell you the other example. So this PC IP address is let me show you the IP of this PC. So this PC IP address is 10.1.1.0. That is the source IP address. What I'm doing is I am pinging from this IP address 10.1.1.10 to this IP address. This PC IP address is 172.17.1.2. So here the source IP address is so this is an example, the source IP, and we need to have a destination IP address to ping from source to the destination. So this IP packet goes to router 1, and it goes to router 2, and it reaches the web server. So when the devices are on the same network, the source and destination will have the same number in the network portion of the address. So what it says is, like, if this person want to send a message to this person, then first the machine will understand whether they are in the same network. So if you check this IP address 192.168.1.1, 192.168.1.1.9 and 110. So the first three octets are matching. That means both the devices are in same network. That means this particular message, it won't go to this router. It go from this PC, it goes to the switch, and again it comes to this particular server. It won't go to the gateway. So I'll tell you, I'll give you an example here. So this PC IP address is 10.1.1.6. I'll ping from here. Let's see. It first come to this PC to switch, and again it will come to this PC. I'll ping from ping. So the message starts from here. It comes to this PC. It directly comes to this PC. It is not going to this router because the source and destination are in the same network. So if you see this particular circle, this says like these both the devices are in same network. That means it will directly go to the switch and it will directly go to the PC. Devices on remote network. For example, if I want to send a message from this PC to this PC, this PC in different network and this PC is in different network. So that time what happens is this PC is going to send this message to its the default gateway, and the default gateway means router. The router is going to route the traffic to its to this particular router, and this particular router send the message to switch and it goes to the PC. Let's see with an example here. So I'm going to ping 172.1.2, that is this PC4. Let's see how the message goes from PC1 to PC4. So the message come to the switch and it goes to the router. Again, it will come to this router. It reaches this router. Then it comes to switch and it goes to the PC. So since it's ICMP, this PC is going to acknowledge the message. It's going to send a reply again. The reply also going to follow the same path. It goes to the switch. It goes to the router. It again go to this router, and finally when it receives here, you will see an green color tick mark. See, if you see there is a green color tick mark, this means the message delivered successfully. Hello?
Hello. Hello.
Yeah. Yes. So can you hear me now?
Yeah. Audible.
Okay. So this is the message. So when you are sending a message to the same network, it directly goes to the switch and it goes to the PC to the destination. And when we are trying to reach the device which is in different network, it goes to the router. Yeah. So this is the message format. I'll tell you with another for the last point. So when we are sending a message to the different network, so the source MAC address will be the PC MAC address and destination MAC address will be the default gateway MAC address. And if you are sending some message locally, the source MAC address will be this PC MAC address and destination MAC address will be this destination PC MAC address. And during the transit, the MAC address will keep on changing. For example, if this is original source and this is the final destination, when you want to send a message to the server, the IP address, it won't change. The IP address remains constant. The source IP remains constant, but the MAC address will get changed. For example, when he is sending locally, it has this device MAC address and the router MAC address. When the message reaches the router, again the MAC address will get swapped from router MAC address to this router interface MAC address. And when it goes to the destination, the MAC address. So what I'm trying to say is the MAC address keep on changing in the packet, but in the source IP address and destination IP address never changes. Even though if you are reaching from the different destination, the IP address don't get changed. So these all I explained here. Yeah, that's all. I hope I have completed. If you have any questions,
Okay.
please ask me if you have any questions.